Hey everyone, in this video we're going to go over 14b, the graph expectation and variance of the binomial distribution. Sounds extremely exciting. First of all, let's look at the graph of the binomial probability distribution. So in the previous section, in 14a, we looked at the binomial distribution, did it on the calculator, easy peasy Japanesey. But in this section, we're going to be looking first of all at the graph. So these values that are being graphed, okay, are just your probabilities. Okay, so P is your probability of success. Remember that, it's not your the probability of each possible outcome. All right, it's your probability of success. So in example 5, we're looking at the graph of the binomial probability distribution. The number of trials is remaining the same, but we're just looking at different probability of success. So 0.2, 0.5, 0.8. So 0.2, extremely unlikely. 0.5 is fair and 0.8 highly likely. So you can see in A, probability of success is 0.2. So your graph, okay, we call this positively skewed. So for P equals 0.2, the graph is positively skewed. So most of your mostly from 1 to 8 successes will be observed in 20 trials. Okay, so if it was P equals 1, it would be 20 out of 20. Okay, or closer to 20. So here we've got P equals 0.2, so we would expect fewer successes because it's quite a low success rate. Now, if you're wondering whether to call it positively skewed or negatively skewed, I'm just going to show you what I do with when I talk further. I always say, okay, here you are in your pretty little dress, long arms, long legs, at the top of a slide. And you're going down that slide in what direction? This is your positive direction. Okay, so X, when we go in this direction, sorry, I just realized that my arrow doesn't work. We're going in a positive direction, so it's positively skewed. In B, our probability of success is 0.5. Okay, so you can see that it's symmetrical. So we expect 10 out of 20 to be our success. Okay, so 10 out of 20, 0.5. We call this symmetrical because 10 is our middle value. Okay, and it's symmetrical either side. We never say symmetrically skewed. Okay, so if you're a further math student, just know that often students say symmetrically skewed, but I don't think in methods you're going to need to know positive, negative, or symmetrical. But there's just 3 different examples anyway. So for C, probability of success is quite high. So P equals 0.8. So here's your, here you are, long arms again, long legs. And this time you're going down the slide in the negative direction. So it's negatively skewed. Okay, skewed just means it's not symmetrical. Okay, it's leaning towards one side. All right, we're going to look at expectation and variance as well for binomial distribution. So easy to calculate. All right, so your expected value is just your number of trials times probability of success. Your variance is then NP times Q. So they've got 1 minus P, but if you want to remember it as NPQ, and remember that Q is the probability of failure. So your number of trials times the probability of success times the probability of failure. All right, so let's go through some questions. So and also you can graph these on your calculator, quite time consuming doing it by hand. So we're going to do it on the calculator and then you can just transfer it onto your page. So plot the graph of the probability distribution. Okay, so it's written as that's a binomial distribution. So for n equals 10 and p equals 0.2. Okay, so when we're graphing, all we need is number of trials and the probability of success. So let's get the calculator up. Okay, I've actually never done this on the calculator, so let's see if I can remember. Statistics, and then we want to, what do we want to do? Maybe distribution? Okay, so we've got distribution. I can see normal there, which we're going to be doing later. There we go. Binomial. And we just want PD. All right, so let me just see 10.2. I don't know what x is. Okay. What happens if I do x equals 1? Okay, it's not graphing it. All right, I'm going to have to pause. Obviously didn't remember how to do it. Actually, I'm going to just think, I just saw this graph thing up there. There we go. Awesome. So even though I did x equals 1, it's shown me, first of all, you could do, instead of doing it the other way that I showed you in 14a, you can actually get the probability this way as well. But you've also got the graph, okay? And I assume you could probably, can I move the cursor? No, but I can change the values of x. So if I wanted to do 3, excuse me, can I do 3? No. So maybe if I go back and then I maybe need to change 3 there. That's annoying that I can't just move the cursor. You're going to let me move it here? No? All right, so you can see the value there, and it's a shame you can't move the cursor. Anyway, so there's your graph. So you can just transfer it onto your page. If we're going to, it says on the same axes, but I don't think I'm going to be able to do it on the same axes. Let's go back. So calculate distribution. So we want it to be binomial. All right, so doesn't matter what we do for x. Number of trials is 10. No, yep, 10, and this one is 0.8. All right, and I want to graph it. Can I graph you? There we go, it's on the bottom this time. You can see that I chose x equals 2, and there's a very small number. So remember, e is to be replaced with times 10. So it means I'm moving that decimal place 5 spots to the left. So that is going to be a very small number. But you can see that this one is now negatively skewed compared to the other one. So for question C, when we compare the two distributions, the first one, question A, was positively skewed. C is negatively skewed. So the comment on the effect of P on the shape of the distribution. So it just, and I was just noticed here that the numbers should be underneath. That's a bit annoying. The effect of P on the shape of the distribution. So it just moves, I guess, your values to the left or to the right, depending on whether you're a low value of P, you would be on the left side, so positively skewed. 0.8, you're closer to 1, will be negatively skewed. Okay, so your probability is higher, so therefore your x is closer to the number of trials. All right, question 4, find the mean and variance of the binomial random variables with the parameters n equals, okay, so this one's easy. So remember our expected value. Let me just scroll up. Expected value is n times p. So for a binomial distribution, just trying to find the question. All right, it's just n times p. Come on. So n times p. So for question A, we're going to have 25 times 0.2. B is 10 times 0.6. C, 500 times 1/3, and D, 40. Now 20% we can just write as a decimal by doing 20 over 100. All right, so you could just do all them on your calculator, pretty straightforward. All right, question 6, the survival rate for a certain disease is 75%. Of the next 50 people who contract the disease, how many would you expect to survive? So N equals 50, P equals 75%, so 75 over 100. So as a decimal, that's 0.75. So your expected value is just 50 times 0.75. So you can just go ahead and do that on your calculator. Question 8, a binomial random variable has a mean of 30 and a variance of 21. Find the parameters n and p and hence find the probability that x is equal to 20. All right, so your mean, remember, is your expected value, which is np. Your variance is equal to np, and I'm not going to write q because q is the same as 1 minus p, and if I write q, then we've got another unknown. So we just want to write q in terms of p. So np is 30. So and my variance is equal to 21. So I know that np here is 30, so I can just write 30. 1 minus p is equal to 21. And then you can just solve for p. So divide both. You can use solve on your calculator, but I'm just going to quickly do it. 1 minus p. Was that 7 over 10? Okay, so that means p is equal to 3 over 10, which is 0.3. So your probability that x equals 20. All right, actually we've got to do, so we know p is equal to 3, so that means n times 0.3 equals 30. So n, 30 divided by 0.3 is 100. Okay, so we've got those two values now. We can use our binomial distribution. So n equals 100, p equals 0.3, and x equals 20. So on the calculator, all right, let's just go back to the main screen. We want binomial PDF. All right, so x is 20, number of trials is 100, and the probability of success is 0.3. I was just thinking, why am I getting 7.57? So I had to pause just to check my answer, and then I realized the e to the negative 3. So let's deal with that. So the probability that x is equal to 20. Let's get the calculator back up. So we've got 7.576, 7.576 times 10 to the negative 3. So I'm moving my decimal place 3 spots. And how many decimal places? So just 4 decimal places. Just going to put it back up, make sure I've done it correctly. So negative 3, so 1, 2, 3, just rounded correctly, 7, 6, good. Okay, so the tricky one, well, that wasn't a tricky question, but I guess you haven't seen a question like this before, just using the formula for expected value and your variance. Oh, and then we're on to 14C. Okay. Nice short video. Bye, girls.